questions? Okay, this is the recording for Friday, February 2nd, and this is the notes for 5-4, maybe I think part 3. And so we just got through doing this little self-quiz of try these on the next slide. I gave this handout, which is blank right here, and then I had students go over that, so if you want to try them, that's fine. And then some students put them on the board so that you can look at that as well. And I'll just kind of go through. And they're on the YOLA site additionally. And then we're moving on for this. Sum and difference formulas can be used to rewrite expressions such as sine of theta plus n pi over 2, cosine of theta plus n pi over 2, where n is an integer. And these are called reduction formulas as we go through this. So we have 2 problems to do. I'm hoping I can still get through them today. Find all of the solutions of sine bracket x plus pi over 4. Close the bracket. And did it close the bracket on there? Yep. And plus sine of x minus pi over 4 equals -1. And this is over the interval from 0 to 2 pi. So for this one, we need to kind of apply the sum and the difference formula, you know, one time each, I guess. So this is the sine of bracket x, plus pi over 4. And I'm not going to put the pi over 4 in parentheses because I can write it as a fraction, plus the sine of x minus pi over 4 and equals -1. So the first job is just to put these in their respective formulas and think about those equations a minute before we kind of even do this. Do you see that it's the x plus pi over 4, x minus pi over 4 kind of should be reminiscent of those conjugate pair kinds of things. And we're not multiplying them as such, but we should get things in our formulas to expand those out that should maybe cancel and so make the problem a little bit easier as we go. So just a reminder, this first one is sine x cosine pi over 4 plus cosine x sine pi over 4. So that's the first one, and I'll just kind of change. And this is a plus sign, so do be careful, you know, in case that was a minus sign, we'd have to put that back part in parentheses and then distribute through a negative. But in this case, it is just a plus. I'll just add that in red. And then we'll expand, this one. So sine x cosine pi over 4 minus cosine x sine pi over 4, and then just the equal to -1. So I color coded that a little bit just so that you can see the parts that we put on there. So what's the good thing that's just going to happen right away? Yeah, we get some canceling here, and so cosine x sine pi over 4 minus cosine x sine pi over 4. That just simply cancels. We know what the sine and cosine, or in this case, we know what the cosine of pi over 4 is. And so I'll just remind myself, that the cosine of pi over 4 is the square root of 2 over 2. So, you know, from our table or whatever. And so then we get, is it okay if I just right away put the numerical part in front and the sine of x in the back? So I'm going to say that's the square root of 2 over 2 sine x plus the square root of 2 over 2 sine x equals -1. And then when I add these, I get 2 square roots of 2 over 2 sine x equals -1. And then my outer 2's there will cancel. And so this is really, it looked difficult at the beginning, but if we have these formulas, we can just plug things in, things cancel out, and then this becomes the square root of 2 sine x equals -1. Dividing by the square root of 2 on both sides, we get the sine of x equals -1 over the square root of 2. And then we do what with that? Rationalize it. So the sine of x equals negative square root of 2 over 2. And we were given, I'll kind of go back up to the beginning here a second. We were given that this was over the interval from 0 to 2 pi. Because as soon as I kind of come up with this fact that I'm at sine of x equals negative square root of 2 over 2, my mind is saying to me, well, where is that angle? And what is happening there? So I'll just remind myself down here so I can see it. Our interval is from 0 to 2 pi, right? Yep, to 2 pi. And so then when I do my all students take calculus, I know that the sign is negative. So places where the sign is negative is in those two quadrants. My reference angle is just pi over 4. But my two angles, one of them is going to be this angle, which is pi plus pi over 4, which is 5 pi over 4, x equals. And my second angle is the one that's right there, going from here to there, oops, which is like 2 pi minus pi over 4. And so 7 pi over 4, 8 pi over 4 minus pi over 4, x equals 7 pi over 4. And since it was just in this interval, that is it. If it had not given me that interval, then I would add the plus 2 pi in as I go through. So that's the next problem that we had to do. And the last one is a little long again, but it isn't terrible, I don't think. So let me go through those slides. Here's the next one. And this is a verify problem. And I hand wrote it because it's hard for me to type sometimes these on the Smart Notes. So the sine of parentheses x plus h minus the sine of x all over h. And we just want to show that it's equal to this, the cosine of x times the sine of h over h minus the sine of x times 1 minus cosine h over h. Which side are we going to work with? Neither looks super simple. We're going to work with the left side, and the reason is we have this sine of x plus h, and so we can expand that out, and that will be our first job. So if you need a moment to write it down, go ahead and do that. And, while you're kind of thinking about it, look at the formatting of that right side. Do you notice if you wrote that as a single fraction, it would have a common denominator of h, correct? So we're going to keep that common denominator of h and eventually just kind of break that off and kind of reorganize things. So the first thing we're going to do is put that in there. And Thomas, go ahead and tell me what just that sine x plus h, sine parentheses x plus h will be. Okay, and then I'll just write the rest of that. We're working just on the left side, and we're going to kind of see what happens and try to make it look like the right side. And so then as I kind of look at this, I'm going to rearrange things a little bit. And I know I want, when I look at, let's see, this is a little hard because people who aren't in the room. So when I look at this answer, if I had that cosine times sine over h kind of first, that would kind of give me that piece. Does that make sense? So I'm going to move that to the front, and let me get rid of all of that. And then I'm going to move this stuff to the back, because if I look at this, that's got a common factor of sine x times 1 minus cosine x. And if I take that out, and I'm going to take it out as negative sine x, I'm going to write this one first, so that's going to give me the 1, and then that one second. So the first thing I'm going to do is just simply rearrange. Let me get rid of all that yellow. Simply rearrange this so it's in a more convenient order. So I'm going to put cosine x sine h first, and I'll just do a different color. And then I'm actually going to go minus sine x plus sine x cosine h all over h, which I didn't. Okay, so that just made things more convenient for me, I feel like. Now I'm going to split into two fractions my work here, and I'm just going to real quick, well, maybe I won't group that because, oh yeah, I will. Okay, well that didn't give me that much. I wish I could see that still, but that's okay. So now I'm going to separate it into two fractions. So cosine x sine h over h. And then on this next part, I'm going to distribute out a negative sine x. So I'm going to go minus sine x times 1 minus cosine h all over h. So I kind of did maybe two things there, but I think I'm good with that. I pulled out, well, really no, I separated the fractions, and in that second one I pulled out that common factor of negative sine x. And then I'm pretty sure I can just rewrite it the way it was up there. So this was written as cosine x in parentheses times sine h over h. And then this one was written as minus, and then the sine x, and then the fraction of 1 minus cosine h over h. So that was just a matter of putting something in the formula and rearranging it to look like the other side. So, you know, just like these proving of identities or verifying. And at the beginning it just said the disclaimer, h does not equal 0. And so I didn't know there was knowledgeable today until, like, you know, more recently, but now I know their schedule. And so next week we'll talk a little bit about the trig star test and things like that. And the homework check for 5-4 I put as next Wednesday, just to let you know. And so that's this lesson as we go. And have a great weekend.